Imagine a world where you can minimize your worst-case losses and maximize your best gains.
Wow, that sounds incredibly strategic. Just how does this work in the world of artificial intelligence in games?
It all starts with the concept of Minimax, which is a decision rule aimed at minimizing loss in the worst-case scenario.
It's really fascinating how this mathematical principle applies across various domains, including decision theory, game theory, and even philosophy.
So could you break it down?
Absolutely. At its core, when we talk about Minimax, we're also touching on maximin, which is about maximizing your minimum gains.
The application can get convoluted, particularly in more complex games.
Speaking of complex games, how does it fit into zero-sum models? What's the maximin value again?
The maximin value represents the highest assured value a player can get without knowing others' actions.
Essentially, it's about finding that smallest value you can secure, even if your opponents know what you're doing.
Can you give an example?
Sure, consider a two-player game where one player can choose 3 moves and the other 2 moves.
Each player's strategy hinges on not just their own moves, but anticipating the reaction of the other player.
So they have to make decisions based on worst-case scenarios.
Exactly. You calculate the worst possible outcomes and then choose the option that provides the maximum value from those outcomes.
This is the heart of decision-making in games. What's even more intriguing is how algorithms can apply this logic in artificial intelligence.
Wow, that's mind-blowing. But what about the actual payoff in these games?
In zero-sum games, the Minimax solution aligns with the Nash equilibrium.
Nash equilibrium? Isn't that when players settle into a strategy?
Yes, the Minimax theorem states that each player can secure certain payoffs regardless of the other player's decisions.
Is it always that simple?
Not quite. If you assume player 1 plays strategically to secure a payoff, player 2 will always counteract.
So it really becomes a back-and-forth struggle.
Precisely. While every player aims to minimize potential losses, the other player is trying to do the same.
I feel like I'm on the edge of something big here. What happens next? Can you give me an example of a zero-sum game to illustrate this?
Definitely. Let's say player A and player B have 3 options each. When they choose their moves simultaneously, the outcomes change dramatically.
And that's where the dilemma intensifies. Each player's choices directly influence the other's potential gain or loss.
So what if player B anticipates player A's move?
Then we enter a complex cycle of counter strategies, creating a scenario where neither player can confidently commit to a course of action.
They might realize certain strategies yield better results, leading to a search for a more stable strategy.
Stability. That's crucial. How do they establish that?
Great question. In game theory, maximin is often confused with minimax.
So they're different?
Yes, noticeably. Minimax focuses on minimizing the opponent's maximum possible gain, while maximin is about maximizing your own minimum payoff.
And that can change everything in a game, right?
Indeed. In non-zero-sum games, the dynamics shift entirely.
Each player must be more mindful since their outcomes are interconnected.
This sounds even more complicated than I thought.
It gets even deeper. In repeated games, minimax values have paramount importance.
How so?
The Folk theorem, for instance, illustrates how sustained strategies can evolve based on those minimax values over time.
That's so intriguing. I want to explore that more.
Well, there's something exciting on the horizon. A new text-to-video generator service called Minimax from a Chinese company, Hailuo.
It's interesting. One wonders whether they've named their model after that mathematical decision rule.
That opens up so many questions. Listeners, what do you think about the connection between technology and game theory?
Absolutely. Share your thoughts in the comments.
Who knows? Maybe we'll address your insights in a future episode.
I can't wait to hear more.